Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to talk about the Unit 3 review on deductive reasoning, but we're focusing just on identifying the hypothesis and conclusion of a conditional statement and on writing the converse, inverse, and contrapositive of a conditional statement. Let's begin just by talking about some definitions. First of all, a conditional statement is a declarative sentence in two parts. The first part is called the hypothesis, and the second part is called the conclusion. We can see this by here. This sentence we have the words if and then, and those are kind of our giveaways. The part of the sentence after the word if is the hypothesis of the sentence. And the part of the sentence after the word then, is the conclusion. One thing to remember is that the word if and the word then are not actually part of the conditional statement. Alright. Now, we want to identify the hypothesis and the conclusion of these statements. If we just kind of go through these, I need this mode. There we go. The hypothesis of this first statement is M is the midpoint of AB, and the conclusion is AM equals MB. Okay, here the hypothesis of this second statement is two lines are perpendicular, and the conclusion is they intersect at a right angle. Now, one thing here that we might want to talk about is the word they. The word they is a pronoun for two lines. So the conclusion is actually two lines intersect at a right angle. Alright, now, this next one's kind of interesting because the word if is in the wrong spot. Okay? It's not in the front. Totally just switched that to green, and it did not switch to green. There. The word if is in the wrong spot. It's in the middle. But it still tells us where the hypothesis is. The hypothesis is always after the word if. The conclusion is the other part of the sentence. In this case, the English language is turned around backwards on us. And I'm going to talk in a little bit about one time where this is actually going to be a problem for us. But that's a little further down the road. Okay. Alright, so more hypothesis and conclusion. Notice here that the word if is in the wrong spot again. It's in the middle instead of at the beginning. That means that the hypothesis, is still after the if statement. Okay, the conclusion is still, it's going to be this first part. Alright, what happens first? You threw her into a lake. Well, and then what happened? Oh, she floated. Hypothesis, conclusion. Now, this one's interesting. All right angles are congruent. This type of problem doesn't have an if or a then. So what we have to do is we have to split it on right before the verb. Okay? The hypothesis is the subject of the sentence, and the conclusion is the predicate of the sentence. But we have to do a little bit of work to figure out what it actually is. So what are we talking about here? We're talking about angles, right? So we would say if an angle is a right angle, we don't want an angle, do we? We need more than one angle. We need two angles. Let's see here. So if, oh well, whatever. It's blue. If two angles, oh man, are right angles, blah. then they are congruent. You know what? It works. You get what I'm talking about. Okay. Perpendicular lines form 4 congruent angles. All right. Again, we're splitting it on the verb. So we have perpendicular lines. Well, what does it take to have perpendicular lines, right? We have 2 lines are perpendicular. That's your hypothesis. Your conclusion is that they form 4 congruent angles. Okay, so that's the idea. You want to split it up on the verb. Okay, conditional statements or related conditionals overview. There are 3 types: the converse, where we switch the hypothesis and the conclusion; the inverse, where we negate the hypothesis and the conclusion; and the contrapositive, where we both switch and negate the hypothesis and the conclusion. We also have the idea of logically equivalent, and of the related conditionals, the original statement and its contrapositive have the same truth value all the time, and the converse and the inverse have the same truth value. I feel that I should tell you that this is on the test. Alright, it's a question, and I say check the boxes for all the statements that are logically equivalent to blah blah blah, and you gotta select all the ones that are logically equivalent. So this is definitely a test question. You need to pay attention to this idea about logically equivalent. Alright, so let's write some converses. Alright, so up here it says, if an animal is a chimpanzee, then it is an ape. To do a converse, okay, we have to identify the hypothesis and the conclusion. So this is the hypothesis, this is the conclusion. Alright, so we say, we're switching it around now, it is an ape becomes the hypothesis, and an animal's a chimpanzee becomes the conclusion. Hi everybody. Yep, I'm recording. If an animal is an ape, then it is a chimpanzee. Okay, and I'll leave this other one for class. But basically, if 2 lines are form congruent angles, this has to switch places with this. So we would say if 2 lines are perpendicular, then they form congruent adjacent angles. We want to write the inverse. To do an inverse, all we have to do is, whoops, that's not what I wanted to do. Okay, let's back off that. Alright, there we go. All we have to do is drop the word not. So if an animal is not a chimpanzee, then it is not an ape. Thank you. I just got an awesome Superman shirt. The whole internet knows that now. If 2 lines do not form congruent adjacent angles, then they are not perpendicular. Tomorrow's superhero day, in fact. I think I'll wear it. Okay, so that's inverse. The contrapositive means we have to switch it and negate it. So remember, negating it's easy, right? We're just going to drop the word not. If an animal is not a chimpanzee, come on, right. There we go. Oof. Then it is not an ape. Oof. That was, the pen is just not behaving right now. I have 2 lines. Oh boy. Alright, 1 second here. Sometimes if I just put the pen back in and then take it back out, it'll straighten itself out. Okay, whoops. Eraser. Then again. Okay, if two lines do not form congruent adjacent angles, then they are not perpendicular. Now these are inverses, right? So what we have to do next is switch them around. So this becomes the hypothesis and this becomes the conclusion. So we say if it is not an ape, then an animal is not a chimpanzee. Or we say if two lines are not perpendicular, then they do not form congruent adjacent angles. Again, we're switching. This becomes the hypothesis and this becomes the conclusion. Alright, logically equivalent. If we just think about this for a second, we want to talk about the truth of these statements. So if an animal, first of all, if an animal is a chimpanzee, then it is an ape. This is true. Chimpanzees are apes. Right, but if I say if an animal is an ape, then it is a chimpanzee, this statement is false because gorillas. Alright, gorillas are apes and they're not chimpanzees. So gorillas is a counterexample to this converse. And this one says if an animal is not a chimpanzee, then it is not an ape. This is also false. Again, we can say gorillas, or you can say like orangutans or something like that. And finally, if an animal is not an ape, then it is not a chimpanzee. This is a true statement because if you're like a horse, right, then you're not a chimpanzee. In fact, if you're anything but an ape, then you have to be an ape to be a chimpanzee. It's a requirement. Okay, so this is true as well. And what we want to notice is that the original statement and the contrapositive had the same truth value. And the converse and the inverse had the same truth value. And this is always true, and it's what we call logically equivalent. Okay? Alright, finally, we want to talk about an idea called biconditionals. A biconditional is what happens when both the converse and the original statement are true. So two lines form congruent adjacent angles. They are perpendicular. This is true. This comes from Euclid's definition. And then if two lines are perpendicular, they form congruent adjacent angles. This is also true. See, this is the converse. Okay, this is the original statement. And that allows me to do something called a biconditional. A biconditional is a statement in if and only if form. And notice that we've taken this part. So two lines are perpendicular. If and only if they form congruent adjacent angles. If and only if means that you can read it both ways. You can read it this way and you can read it this way. Alright, so two lines are perpendicular, then they form congruent adjacent angles, or they form congruent adjacent angles, then they're perpendicular. Okay, so biconditionals.